In the previous video, we defined what is meant by 0. Now, our intention is to go and find out what is a negative of a number. For example, if you have a number 2 there, and then our negative of a number is -2. If you have -2, then +2, right? So this is how we are going to deal with the negative number. So that's what we mean by a negative of a real number. Okay, so in order to find out the negative of a real number, let's go first with the intuition. Okay, so this is our 0 if it is our 2, and this is our -2. So this is our negative of a +2 or negative of a -2, right? So how we defined the numbers? We defined the numbers with the cuts. So what is cut basically? Cut basically is a set. This cut is a set of all rational numbers, right? This is a set of all rational numbers less than 2. So we can take like this, because we are just collecting the rational numbers on all the rational numbers, and you can check this definition very much holds within our three properties of the cut. Okay, so but the problem is we don't know the real numbers at the beginning of the definition. That's why we didn't use this. Now we can modify the definition to this one, right? So these are all the rational numbers less than 2. Coming to the -2, what will be the cut -2? Similarly, this is also set of all rational numbers such that those rational numbers are less than -2. That means these are. One can observe here -3 is there, -4 is there, or -2.5 is there. Here also 2.5 is there, but plus version of it. 3 is there, 4 is there. So it contains, this -2 contains all the rational numbers whose positive versions not belongs to the 2, right? Does not belongs to the 2. So can we say -2 is a set of all rational numbers such that their negative version, these collection of these rational numbers whose negative version is what is the negative of a -4 plus 4, what is the negative of a -3 plus 3. So such that -p does not belongs to 2. Can we take like that? Then we can get -2. That is, if it is alpha is there, then minus alpha, right? Can we take like that? The problem is here 2 does not belongs to. This is the problem. 2 does not belongs to the cut 2. So if our alpha is a rational number, we get this problem. If our alpha itself a rational number, then what happening here is our alpha does not belong to the alpha, because this is a cut. Okay, this is a this is the reference of a rational number. Okay, so this rational number belongs to the alpha cut. Then our here for example, our here example -2 contains -2 because 2 does not belongs to alpha, so that therefore -2 should be here. So this says that this maximum of the -2 present, that is the maximum element in the -2 cut is present. This is a violation of the third property of a cut, to be a cut. So what is our plan to change or to avoid this 2 especially -2 to be in the -2? So for that, you can observe here, just take, this is 2. Okay, this is we don't want 2, but we want all the rational numbers after 2, right? So what if our definition is like this? Say beta is the set of all rational numbers. Okay, set of all rational numbers, sorry, not beta, -2, let's take -2. It is a set of all rational numbers such that this negative of a rational number Okay, this negative of a rational number should be such a sorry, not negative of a rational number should be like there should be one more rational number less than the negative of your rational number, even though this is less than minus p, this q also should not belongs to minus 2. How to look it? Then let's we'll rewrite once again the definition. Like we'll rewrite once again. See, here we have 2 and say this is our number. Can we say this is our minus p? Okay. So this is our minus 2 and this is p which belongs to there. Therefore, this is our minus p. Okay. So is this the negative version here? Okay, negative version need not be a negative number. We not yet defined the negative numbers. I'm just talking about negative version. Okay, negative version of a p. Okay, so we should find such a p that there should be another number in between. What does that means? If you subtract a positive number from your minus p, then also the resultant number should not belongs to 2. So this now see 2 here. Can we say minus 2 belongs to minus? Sorry. Can we say minus 2 belongs to minus 2? See, what is the negative version of the minus 2? This is plus 2. Is there any number or is there any rational number less than minus 2 which does not belongs to the minus 2? That is not possible, right? Then 2 will not be a cut. Since 2 is a cut, all the definition of the 2 itself is a set of all rational numbers less than 2 itself. So there will be no rational number less than 2 but not in 2. So such kind of numbers are not possible. So our minus 2 clearly not belongs to minus 2 cut, right? So this is okay. But what about the other numbers like minus 2.0001? You can find like 2.0001 which is less than 2.001. Though this number does not belong to 2. Why? This is not a rational number less than 2. This is a rational number greater than 2. So minus 2.001 belongs to minus 2. So now we can define what is a negative of a rational number, negative of a real number. But we don't know that. So let alpha belongs to r be a fixed number, be a fixed real number. Okay. So how to define the negative of it? Let us call this as beta. So this is a set of all rational numbers, such that minus p, I'm just taking that minus p minus r, that means there exists an r. Okay, minus p minus r does not belongs to alpha for some r greater than 0. You can choose r based upon the p. This is not universal for the complete set beta. Okay, this is depend on the p. So is this our definition? What we are saying here, this is our alpha, and we should find out p that even though if you subtract some number, we need we not telling that subtract every number, just some number, so that you see this is our p and p minus r. So this is our minus p, so this is our minus p minus r, right? So even then this is outside. This is outside of the p. So if it is possible, then that set looks like negative of a number, but we don't have a guarantee for that. So for that we need an explanation which requires the logical support. So we can see that very easily by the Archimedean property. You try the Archimedean property only for the rational numbers. It's actually easy one, and you will get the answers in the internet also. So I will go to use that Archimedean property while we are going to prove it logically. So in the next video we will prove it logically. So this is how to look a number which is a negative of a number. Like I see here, I can once again explain this one. Here we have 2, sorry, let's take pi. Okay, let's take pi here, minus pi, and we should choose a rational number here. If this what is the guarantee that this belongs to the beta of a pi? Like this is the beta of an alpha, let's call it beta of an alpha. What is the guarantee? That means then we should find an r, a positive number. Okay, we should find a r, a positive number, such that you multiply the minus p. See, multiplication of a rational number is already defined. That means we assume that we know we know everything about the rational numbers, at least these structures, right? So minus p is possible. Then you subtract from that minus p, subtract r. If it not belongs to the cut which is responsible for the pi, then that number belongs to the beta of the pi. Now the question is, you collect all such kind of numbers. It is a cut. Whether is it a cut, and is alpha plus beta is equals to 0 star. Why is 0 star? 0 star is our 0. So is alpha plus beta is going to give you 0. So that is what we are going to see in the next video.